20.2, connecting intercepts and linear factors. So what are linear factors? When we look right down here, we see a factored form of a quadratic. Now, when we say factored form, we're going to deal with this in 21. But a factored form is where a quadratic in standard form is broken down to its pieces. Now, what the linear factors are, they give us on the graph where it crosses the x-axis. Now, remember, crossing the x-axis is referred to as zeros. So really what we're doing is we're taking this equation and we're setting it equal to 0. Now, that's important to understand because what would make this 0? It's not 4, but it would actually be -4. What would make this one 0? It would be a +2. Those are the intercepts of the quadratic function in this form, factored form. So what that's going to allow us to do is to be able to draw the function itself by finding the axis of symmetry and other points, but it's also allowing us to understand how a graph can give us solutions to a quadratic function. So exactly how would I find the vertex itself as well? Well, one thing we do know is that the axis of symmetry goes right through the middle. Well, these intercepts are equally distant from each other, so where would be the axis of symmetry? It would be right down the middle here, which would be here, which would be the line x equals -1. Now why is that? Because the distance from -1 to 2 would be 3, and the distance from -1 to -4 would also be 3. So let's go on with this. It says use a graph to determine whether 2x squared plus 5x minus 12 is the product of the linear factors 2x minus 3 and x plus 4. Okay, how could you do that? A couple ways, and we'll see this in the examples, but one way you could do that is just to multiply these and see if you end up with this, and that's going to be part of what we do. So here it is asking you to take this one and write it in standard form. So you got to do the product, doing FOIL or distributive or Punnett square or whatever, then distribute the 2, and then here is your standard form. Now again, the great thing about a factored form is when you have factored forms, it gives us the intercepts, the zeros of the function. So what we're going to do is go ahead and go down here to write one in standard form. So I'm going to do one real quickly here just to review. So the first thing I'm going to do is I'm going to multiply the two binomials. Now to do that again, I'm going to do a Punnett square here. So you can use whatever method you want to. So that's going to be x squared, that's going to be a +3x, it's going to be a -1x, and then that's going to be a -3. They're your like terms on the diagonal, so I end up with x squared plus 2x minus 3. So then I have 4 times x squared plus 2x minus 3. Go ahead and distribute the 4, and I end up with 4x squared, plus 8x minus 12. And there it is in standard form. So then here is where it talks about looking at the intercepts in factored form. So the intercept here would not be -1, but +1, because remember the intercepts are the zeros, so it's what makes this 0. The intercept here would be 3. So it talks about it right there. It gives you another example down here that you can work. We're going to term problem. So it says find or write each in standard form, determine the x-intercepts and zeros of each function. Okay, so before we do the standard form, we're actually going to do this portion of it. So what is the intercept here? What would be the 0? Well, that would be x equals -5. Now, another way you could look at that to help you, remember if it's the 0, you're trying to set x plus 5 equal to 0. How do you get that, or how do you solve that? You subtract 5 from both sides, and then you get x is -5. Okay, so that's another way to look at it. Again, if you just understand the basic principle here, you can kind of look at it and determine what's going on and how to get it. So let's just go back. Let's clean this up a little bit. So what is that one? X is -5. What is that one? X is -1. So those are my zeros or my x-intercepts, however you want to think of it. They're one and the same. What's the standard form? Again, you got to multiply. I'm not going to write this out, but you should be able to do this. You're going to get -2 times the quantity x squared plus 6x plus 5. Distribute there, and you get -2x squared, minus 12x minus 10. And there's the standard form for that quadratic function. And if you want to, go ahead and take a second to try number 10, and then we'll look at the answer. Okay, so what you should have ended up with was 5x squared minus 20x plus 15. And then for your intercepts or zeros, you get x equals 3 and x equals 1. So then down here they go to how do you write a quadratic function given your x-intercepts. So again, they go through an example here worked out. Another one that you can fill in. And I am going to go immediately here. Now, the thing about the example they did, they want to do it when you have different k values. Okay, now what was k? K was, remember, the factored form. If you go back in the lesson, the factored form was y equals k times x minus a, x minus b. So the k is your coefficient out front, is all that is. So what we're going to do is we're going to go ahead and do each case here. So we'll do number 12. So what do we have? Well, the first thing we have is y equals, if my intercept is 1, remember my factor is x minus 1. Because if my intercept's 1, we're thinking about what makes this equal to 0. So that means it's minus 1. And then the other one would be x minus 8. You can always remember they're just opposites of each other. So then I have to do my k here. Well, I have 3 different ones to do. What I would probably do first is I would go ahead and multiply my 2 factors here. So if I multiply that out, I'm going to do this real quick, you end up with that. Now you can do your 3 cases. So then I can do when k is 1. So if I do 1 and multiply all of this by 1, what do I end up with? I just end up with x squared minus 9x plus 8. If I do when k is -4, I'm distributing -4 over this. So I get -4x squared plus 36x minus 32. And then my last case is when k is 5. So I distribute 5 again over this, and if I distribute 5, I get 5x squared minus 45x plus 40. So that's what it's asking you to do here. So the elaborate questions real quick. If the x-intercepts of a quadratic function are 3 and 8, what can be said about the x-intercepts of its linear factors? They're the same thing. All that's different is when we talk about it in reference to linear factors, we're writing it as x minus 3. That's a linear. Why is it linear? Because the exponent here is 1. But when I write the other linear factor, x minus 8, multiplied together, that gives me a quadratic because x times x is x squared. So when we talk about the x-intercepts of a quadratic being 3 and 8, its linear factors are the exact same thing. If a quadratic function only has 1 0, it has to occur at the vertex of the parabola. Using the graph of a quadratic function, explain why. Well, that's real easy. If here's a graph, the only way it can have 1 0 is it touches the x-axis only one time, which means it has to occur at the vertex somewhere like that or something like that. Otherwise, if you draw a function that crosses the x-axis twice, it's going to have two zeros. So the only possible way that a quadratic can have one zero or intersect the x-axis one time is at its vertex. And that's a special case, and we'll look at that later on. How are x-intercepts and zeros related? They're the same thing. What would the factored form look like if there were only one x-intercept? Okay, so let's build on this up here. Let's say the x-intercept was at 2. So that would be x minus 2. Well, how many times does that occur? Well, it actually occurs twice. It just happens to be the same point. So if I'm looking at, let's say, this example up here, and that's my point, and let's say that's at 2, then that's where the 0 occurs. But because it's a quadratic, it occurs twice. It's what we call a double root. Now, how would that look in a factored form? Well, that's what it would be, but what you're going to see is this, a perfect square trinomial. And that's why when we were doing in Module 19 and 18, learning how to multiply and looking at specific examples of vertex form, that would be a special case where the vertex is on the x-axis itself.